All right, so here in chapter 7.8, we are solving radical equations. This time though, we have variables on both sides of the equation. So our first step is the same as before. You want to isolate the radical. Now in some of these, you might notice two radicals, okay? If this is the case, then you want to put them on opposite sides of the equation, all right? Once you've done that, you're going to do the same step of undoing the radical, right? Use inverse operations. So if you see a square root, then you want to square both sides. If you see a cube root, then you want to cube both sides. And if you see the fourth root, then you want to raise both sides to the fourth power, right? Inverse operations. You're then going to solve for x like normal. Now, sometimes you will have to solve a quadratic equation, so do be prepared to factor, all right? Last thing is you do have to check your answer for all of these. Sometimes you get answers that do not work, and these are called extraneous solutions, all right? They appear to work, but once you test them out, they actually do not. So for example 1, if I have the square root of 4x plus 1 minus x equals negative 1, we're going to start by isolating the radical. So I'm going to add x on both sides. That's going to give me the square root of 4x plus 1 equals x minus 1. All right, I'm writing the right side in standard form there. So now, to undo this square root, I need to square both sides. Now be careful here, right? When I square both sides, the right side is not going to be x squared minus 1. Tempting, but that is not correct. Remember, you are taking x minus 1 times another x minus 1. Okay, you have two of them. So your right side, once you FOIL everything and distribute, you're going to get x squared minus 2x plus 1. And then we know that on the left side, the square and the square root would cancel out, so we just get 4x plus 1. All right, if we solve, I'm going to isolate all my terms. I'm going to try to get everything set equal to 0. So I'm going to move the 1 over. I'm going to move the 4x over as well. So if I subtract 1 on both sides, and then if I subtract 4x on both sides, we can see that 0 equals x squared minus 6x, because these ones do cancel. So now I have a quadratic, right? We see we've got x squared here. So I'm going to go ahead and factor using GCF would be the best method here. So we're going to take out an x. I'm left with x minus 6. And so I can see that my two possible answers are 0 and positive 6. All right. So you do have to test these out. All right. So we're going to plug in a 0 and see if it works. Then we're going to plug in a 6 and see if it works. All right. So let's start with the 0 here. So if I plug in a 0 into my original equation, this would be 4 times 0, which is 0, and 0 plus 1 is 1. Square root of 1 is 1. If I then subtract, we said x is 0, 1 minus 0 equals negative 1. That is false. That is not true. So when we plug in a 0, we actually do not get a true statement. So 0 is not going to be one of my answers. Now let's go ahead and let's test out the 6 and see what we get with the 6. So I'm going to plug in 6 here. Let's see. So replace the x with a 6. 4 times 6 is 24. Plus 1 is 25. Square root of 25 is 5. And then we're replacing this x with a 6. And 5 minus 6 does, in fact, equal negative 1. So we do get a true statement here. That means that 6 is a solution. 0 would be an extraneous solution. So your only answer for this problem is 6. All right, so x equals 6. That's the only value that would make this statement true, is if x is equal to 6. Let's go ahead and try this second example here. All right, here we have the square root of 8x minus 11 minus the square root of 3x plus 19 equals 0. So let's go ahead and solve this. In this case, we have two radicals. So like we said, we want to isolate on either side. So I'm going to take this one and move it over to the right side by adding the square root of 3x plus 19 plus the square root of 3x plus 19. So now we have the square root of 8x minus 11 equals the square root of 3x plus 19. And to undo a square root, we need to square both sides. So I'm going to square both sides here. Square and square root undo each other, so we just have 8x minus 11 equals 3x plus 19. I can then solve for x. Let's move the 3x over to the left. So I'm going to subtract 3x on both sides. And then let's move the negative 11 over to the right. So I'm going to add 11 on both sides. 3x's cancel, 11's cancel. So 5x equals 30. And we'll divide both sides by 5 to find out that x is 6. Okay, we do have to plug this in. I'm not going to do this again, but if you plug in the 6 for x, you do figure out that it is correct. So this does actually work, and 6 is, in fact, an answer if you check your answer. In problem number 3 here, we are again looking to isolate the radical. So I'm going to go ahead and add x on both sides. These cancel out on the right, leaving me with x minus 10 on the left and the square root of 6x minus 5 on the right. So now that I have my square root isolated, we're going to go ahead and undo it by squaring both sides. We see that the square and the square root undo each other, so I'm just left with 6x minus 5 on the right. On the left, again, remember, this is really x minus 10 times another x minus 10. All right, so once I FOIL everything, we're going to end up with x squared minus 20x plus 100. I can then set this equal to 0. We have a quadratic, so I'm going to try to set equal to 0 and then factor. I'm going to move the 6x over to the left by subtracting, minus 6x. And then I'm going to try to add the 5 to the left side. So we see that the 5's cancel and the 6's cancel, leaving me with nothing on the right side. And then on the left, we have x squared minus 26x plus 105. So we're going to try to factor this. I'm looking for two numbers that multiply to be 105 and that add up to equal negative 26. All right, and hopefully you realize that those two numbers are negative 21 and negative 5, and negative 21 and again negative 5 will work for both of those scenarios. So that means this factors to be x minus 21 and x minus 5 equals 0. And so we get answers of 21 and positive 5. So again, you do have to go back and plug these in. So when I go ahead and I plug in positive 21, I do get that to work out. Okay, that does give me a true statement when I plug in positive 21. When I plug in 5, however, we get a false statement. This is not true. Okay, we can just double check on that really quick. If I plug in a 5 here for that x value, we get 30 minus 5 is 25, and the square root of 25 is 5. If I take a negative 5 plus 5, that does not equal the negative 10. So that does not work out to be true. However, if I do plug in a positive 21, that does work out to be a true statement. All right, so trust me when I say plug in that 21, you will get this right side to equal negative 10 there. All right, last example here, we have x equals the cube root of 4x cubed minus 24. So for a problem like this, we have a cube root. Now it's already isolated, which is great. So to undo this cube root, I just need to cube both sides. So I'm going to cube the right and I'm going to cube the left. We know that the cube and the cube root cancel out. So x cubed equals 4x cubed minus 24. And then I'm going to try to get the x's all by themselves. So I'm going to subtract that 4x cubed on both sides. And then we get negative 3x cubed equals negative 24. Let's go ahead and divide both sides by negative 3. And we see that x cubed equals 8. And if x cubed is 8, then when I take the cube root of both sides, we know for sure that x is going to be 2. All right, so x is 2. Again, it is important to double check your answer. So when I plug in a 2, you do find out that this is in fact a true statement when you plug in the 2. All right, so remember, isolate your radical, use inverse operations, and then once you solve and get your answer, really be sure to plug it in and double check to make sure it actually is a solution.